got 9. I got those up. That was okay, but 9 those down. Okay, so it's the control circuit that's used to there. Okay, so that will work. We just need more authority on the canard.
That's how we're on flight.
Surface is bigger, and make sure that you're getting the control.
Did it come off as I designed?
It's only the edge.
Off. Oh, that's annoying. It was designed to snap off.
But the other issue is, this isn't going to work in one course. Okay? Because canards are ground hunters. They need lots of runway. So once they get up, they boogie well, but they just need lots of runway to get going. But yeah, if you work on the canard control service, we'll get there. We'll get there with it.
Yeah. And the CG.
Yeah.
I think the back wing isn't getting enough lift, that's why a lot of times just...
No, but I've also got no control authority at the front.
Yeah.
And your relative
Canard's
angle of
going to do its own
incidence
thing.
between the two is important. You guys need to look that up and see what your relative incidence should be.
Well, this one's the setting angle of the canard was 2. The setting angle of this was
about 0.
0.
So you're setting your canards how much?
It's about 2 degrees.
2 degrees, and you're setting your mains that. Okay, so let's explore this. Right, so as we pitch up, okay, we're increasing the angle of incidence. Right, so we start off with 1 degree here. So call it 0 degrees the main ring. We start off with 2 degrees there. As we increase, okay, what's going to cause the stall to occur? What is it? Angle of incidence, right? Relative angle of incidence. Okay, so with it like that, what's the angle of incidence on this thing compared to this thing?
2 degrees higher.
It's going to be greater, isn't it?
Yeah.
So, if they're the same section, let's assume they are, okay, which is not going to have much to do with it, which wing's going to stall first the way you've got it?
The canard.
The canard, okay, cool. So that's going to behave itself. So we get up, the canard should go first and bob down. So, but we've only got a couple of degrees in there.
Yeah.
Okay, so that couple of degrees may well not be enough to do it. Okay.
Another thing that we worried about was that apparently I've read the problem with tractor configuration on canard is the prop wash tends to keep air attached longer than it should be. So they were saying, I couldn't go push it with this.
I think there are more fundamental issues of the fact that that only goes down, doesn't go up, and that doesn't move at all. Guys,
That's more with the actual
the
thing we couldn't get it to work.
Yeah, but if I've got no control, I've got no control.
Yeah.
Okay, and so having control is a pretty key part of it.
Yeah.
Cool, it's got potential, guys.
Cheers.
Oh, got a lot of work to do, I think.
So first,
I think if we just redo the canard, it's pretty good.
and he
Oh,
said
he was saying
you also
to start
said
off with just,
put the angle slightly higher as well.
Yeah, maybe.
So it's still like a bit further forward.
Maybe. Increase the fitting angle.
And yeah, just actually get the linkages to work. That's the main thing. It was like, we just don't have.
The one doesn't work. Like that's the thing because it's kind of hard to see. But if you look in there, you can see that one of the servos, the servo that we're using is on it's not in the middle. It's on one side, so it's going to favour one side over the other. Also, there's this kind of movement that I just can't stop. So it's annoying. I was going to kind of build like maybe a rail or something that it sits on, but that's complicated. Could do it with the steel wire maybe, because hasn't got a lot of friction. So it's this one that hasn't got. This is the one with the kink in it. So.
Oh, there's a basketball.
Where's that kid? Where's that kid? Everything's gone by that, dude. What?
Ah, yeah, Jimmy.
Can we go back to unit to build it?